Section 4.3, Hamilton paths, Hamilton circuits, and the traveling salesman problem. Okay, so this is the big one in terms of why we're even doing this. Now, the traveling salesman problem gets formally defined later on. We are doing it on the very small scale. UPS and FedEx and all of them, they're using computers to figure out the best route each truck has to take. So think about it. One truck might have to visit 20, 30 houses in a day. I actually don't even know how many. I should probably talk to my UPS guy. And these delivery companies have dozens of trucks. So each of these each of these trucks have their own specific routes they have to take to get through all their deliveries for that day. And that's where computers are going to come into play. For us, we're going to have at most 5 vertices because there's a lot of work you'll see involved with finding the best route to take. And because we're not using computers and we're doing this by hand, 5 is more than enough. Okay, so with that said, let's define some big things. A Hamilton path is a path, really, that passes through each vertex once. A Hamilton circuit is a circuit that passes through each vertex once. Let's talk about why these definitions are important. The delivery person does not want to come back to visit your house again. They want to drop off all your stuff and move on to the next one. Drop off all their stuff and move on to the next one. So we need these definitions because they want to say, hey, you don't come back. You just visit it and move on. So the big one that's more important is a Hamilton circuit because the truck leaves the warehouse and the truck wants to return to the warehouse. So we want to be able to end where we begin. Now don't freak out. Hey, you said it passes through. It's still correct. The truck leaving the warehouse is the passing through portion. You could return to it as long as that's the only one you return back to. Because we want the truck to get back. We don't want it to get stuck on the side of the road. So Hamilton path, really not too important for the traveling salesman. Hamilton path would be important if, for instance, you were doing a tour of cities in America and you wanted to visit each city once. That would technically be a Hamilton path. So you may have seen that road map on the internets where you can visit all the state capitals and it actually shows you the minimum route you would take. That would be a Hamilton path, assuming that you don't begin and end at the same. If you did begin and end at the same, then it's a Hamilton circuit. Okay, now that we have these two down, let's talk about the big definitions so far in this chapter. So everything was a path, and then a path where you start and end at the same place is a circuit. And a path where you use all the edges is an Euler circuit. So if an Euler path and a circuit got together, they would make an Euler circuit. So an Euler circuit, you could say, is a circuit that uses all the edges. You could say is an Euler path that begins and ends at the same place. Or you can say an Euler circuit is a path that uses all the edges and begins and ends at the same place. Gah. So there's a bunch of ways to define it. Okay, now the middle to the right-hand portion of the image here. A path, a special type of path is a circuit where you begin in the same place. If you pass through each vertex once, that's a Hamilton path. So if you combine a circuit and a Hamilton path together, they make a Hamilton circuit. So a Hamilton circuit is a circuit where you pass through each vertex once, or you can say a Hamilton circuit is a Hamilton path that begins and ends at the same vertex. So I'm going to ask you to watch the video distinguishing between the different types of paths and circuits. Basically, for this one, you're going to be picking the best answer for the given image in the given sequence. All right, good luck.